resource file called the colors.xml file. This is present in this res folder for resource. Go to the values and the very first file you find is the colors.xml. The purpose of this file is to have the code lines mentioning all the set of colors that are going to be used in the other files created, especially the activity underscore main.xml file. The very first set of the colors is the general set of colors, ending with the white, especially for the text view and the edit text views. The second set of colors is for the app background. The combination of these three colors will create the background for our app. The third set of colors is for the text which is written on the buttons. The fourth set of colors is for the clear button. We really want our clear button to stand out from rest of our regular buttons. So we are going with the red accent and the red background for this clear button. The next set of colors is for the equals button. We are going with the green accent and the green background for the equals button. And the last set of buttons is for the math operator colors. The math operator buttons, including the plus, minus, divide into. So for this math operator buttons, we are going with the purple colors. So this XML file is called the app underscore background.xml. As the name suggests, we are creating background for our app. To do so, the very first thing we have to do is mention the first two tags as selector and item, and inside the item tag we will have the shape tag, and we will make our shape as rectangle, and in the design also you can see the effect. The very next tag that follows after the shape is the gradient, which has 4 attributes inside it. The first 3 being the combination of colors we want, the start color, center color, and the end color. And these colors are taken from the at color, that is the colors.xml file which we have already created previously. The fourth attribute mentions angle, that is 45 degree, and this angle is supposed to be 45 or multiple of 45 in the range of 0 to 315. And if it is not, let's see what happens. Let's say we give 10. What you see is that white effect that we had at the borders vanished. Let's make it back to 45. Now the white effect comes back. Let's make it 90. The white effect remains, only at a different angle. This resource file is called the strings.xml file. It is found in the resource folder. Go to the values, and the second file you find is the strings.xml, just below the colors.xml file. The purpose of this file is to store all these strings that are to be used in the other files, especially the activity underscore main.xml file in our design. The way we mention the strings is we use the tag string, and to reference it we use name, uh, and the actual string we want to display in our design is written just before the closing of the tag. So this is the first line of the code, is for the name of the project. The second line of code, the display hint, is for the enter value string, where the user will be able to enter the value. So he has to be directed that he has to enter a value at a particular place. So the user will be able to see the string, enter a value, and there he will be able to put the cursor and write his value. These set of strings are for the numbers of our calculator from 1 to 9, sorry, from 0 to 9. And the second set of strings is for the arithmetic operators, equal to and parenthesis, also the clear C button. The last set of strings is for all our scientific functions, including sine, sine inverse, cos, cos inverse, tan, tan inverse, etc. Also logs, natural logs, absolute values, pi, e, etc. And the extra tag you find here is sup superscript small, is used for values which we have to mention as powers or exponential values. For example, sine inverse, it has -1 at the top, so that -1 has to be small, and that's why we use this superscript small. Similarly, for the cos inverse, tan inverse, and similarly we will have for x squared text, and also for x power y text, in which y has to be the power to x and it has to be smaller than x. This resource file is called the button background.xml file, and it is present in the resource folder. Go to drawable, since it's a drawable resource file. The fourth file we find here is the button background.xml. Now, as the name suggests, it is supposed to help us create the background for our buttons present in the calculator. Now, as usual, we will start with the selector and the item tag, followed by the shape tag, and the shape we mention here is the rectangle, as you can see in the design in the right extreme as well. Then the three more tags which follow are solid, corners, and stroke. The solid helps us to fill the color for the background of our buttons, and the corners help us get rid of the pointed corners. Since we mentioned 25 dp, we are able to get rid of the pointed corners and get the curved corners. The third tag is the stroke, which helps us to give borders to our buttons, and the color for our border we can get from the colors.xml obviously, and the width of the border what we want we can place it here. Here I have placed 1.5 dp. Is another drawable resource file present in the drawable folder of the resource folder. It is pretty much the same as we discussed previously for the button background.xml. Only the colors are different, so we have changed the colors, and obviously the colors are derived from the colors.xml file. This is yet another drawable resource file. This is subjected to the clear button. Everything remains the pretty much same. Only thing we need to change is the color, and here for the clear button we really want it to stand out from the regular buttons, so we are going for a very vibrant red color. That's it. This is yet another drawable resource file present in the drawable folder of the resource folder, and as the name suggests, equals button background.xml, it is supposed to deal with the background of the equal to button. So the color of the background for the equals button we want is green, so we have mentioned green, deriving the color obviously from the colors.xml file using @color, and the stroke we want is green accent, that is the border we want is the green accent, again deriving the color from the colors.xml file. And the corners help us get rid of the pointy corners, and since we mentioned the radius 25 dp, we are able to get curvy corners. This backspace.xml file is a drawable resource file which will help us retrieve the backspace or the clear symbol. The thing is, the symbol is already present in the Android, so we just have to access it with a set of dimension, width and height. And to access this, inside the selector and the item tag, we have to use the drawable attribute, and inside the double quotes we just have to write the android drawable /ic _input _delete, and we will be able to access our backspace symbol. Now coming to our layout folder, we get to the activity main folder, and the first file is activity main.xml. So let's see how we start our layout page. The first thing we do is mention our constraint layout, and inside this all the buttons, text view, edit text views will be contained. So these are the default code lines. The second thing is the layout width and the layout height. It should match parent. It should be as big as the parent, and the background we already created app background, so the background of our app is retrieved in this code line, and the last line says tools colon context is equal to dot main activity, because every layout is connected with an activity. The next is text view. The ID for this text view is previous calculation view, and the next thing we have is the layout width and height to be mentioned as wrap content and not as match parent, because we don't want it to match with the parent and we want it to be in the confined space, fixed confined space. The next thing is the margin top and the margin bottom, layout margin top and margin bottom, which helps us position our text view. The text you can also see in the design is 0, which is mentioned as 0. Let me zoom in. Yeah, this one. Now the color of the text is white. Obviously I'm deriving this color from the color.xml, which we already mentioned previously, and the size of the text is supposed to be 30 sp. Now the last three code lines for this text view is for the constraint of this text view. So the first constraint is bottom to top of this particular ID. The bottom constraint of this text view is constraint, you can see, is constraint to this enter a value, the edit text view. The other two constraints are at the top and the end of this text view. Next is edit text. The ID for this edit text is display edit text. The layout width and the layout height is match parent and wrap content respectively, as shown in the design. The next thing is EMS equals 10, which is the font size mentioned. Then the input type is mentioned as text person name, means the red underlines under the text will be avoided, and also the press of the enter for new line is avoided. Then the hint is given as enter value, as can be visualized in our design as well. The enter a value is seen by the user. Now the text color hint is gray accent, that's why the enter a value string appears to be gray. Then the text size is 48 sp, determining the size of the text, and the color is white, taken from the colors.xml file. Now alignment of this string is text end, that's why the enter a value string is shifted towards the right extreme. Now the layout margin bottom as 40 dp, padding end 10 dp help us to position enter a value string. Now the important for autofills equals no, means the autofill is not important here, and the next four lines which follow are for the constraints, and the last three line of codes in this edit text is for positioning, including the gravity equals and padding right equals 10 dp and right to left symmetry is to be ignored. So the next part is making of yet another constraint layout. This constraint layout can be visualized in our design. This blue box is our constraint layout, and the reason for this constraint layout is we want to fit all our 20 buttons one by one in this constraint layout itself. This is the ID of the constraint layout we just created, and this margin bottom, margin left, margin start, layout height and width determines the dimensions of the constraint layout, and the other two code lines that follow constraint bottom to bottom of parent and constraint start to start of parent, they determine the constraint obviously for the constraint layout. And these tools ignore missing constraints is to just suppress the constraints that we did not give in the code, and the code runs smoothly. Now inside this constraint layout we have 20 buttons. Let's discuss one of them. The ID for this button is mentioned here as button 16. This represents the plus button, as we can see in the design as well. The next two code lines is for the layout width and layout height, which determines the dimension of the button. Then the another three lines of code, the margin left, margin top, and margin start, determines the positioning of the button with respect to other buttons around it. Then the background for the button, a particular color would be needed. So we from the drawable resource, we get the background which we have already created in arithmetic button background, sorry, which is purple in this case. Now the on click add button push will help us to, when a user clicks on this button, it will help the user to actually visualize the plus button on the box, input box. And this text is equal to plus, it means that on the button this plus symbol will be visible. The text color is tan accent, again deriving this color from the colors.xml, obviously. Now the text size is 28 sp, and the last two lines of code determines the constraint of the button plus. Now the code lines for the remaining button go on a pretty much similar structure as we discussed for the plus button case. The only different button is this image button, which has its dimensions reduced to fit in the constraint layout we have created, and it has been constrained to the parent as well as the button, the white button below it. And we have also added this app colon src compat, and from this drawable resource we are retrieving this backspace symbol. And why this src compat is there, because it helps us increase the size and decrease the size, basically resize this symbol without reducing the quality of this vector symbol. So now this activity underscore main.xml is complete, and let's see what our design ultimately looks like. So this is what our design will look like. From this is the top, and let's go down. Now in the layout and activity main, we actually have two files here. First one, activity main XML, and the second, activity main XML. So the codes right now on the screen is for the landscape view activity main.xml. In this, there are not major changes, just what we have to do, the constraint we already created has to be shifted to extreme right, and then in line 317 we actually have to create another constraint for our scientific buttons, and on a similar structure we will create those buttons and constraint and position them accordingly. So now let's go to our design straight. So you can see on the right extreme I have shifted all the previously made buttons of the previous constraint, and a new layout, constraint layout, has been created for the scientific buttons on the left extreme, and the enter a value string I did text view, and the text view itself remains same. So this is our main activity.java file, and we are inside our package scientificcalculator. These are the default inputs which were made, and the last import for the math.mx parser is the manual import. And to make this manual import work in our main activity file, what we have to do is we have to go to the website math.parser.org, and then slide down a little and download this .zip 10 MB file. Once this file gets downloaded, what we have to do is go to this project app folder, libs, and paste this downloaded file into the JDK 8 or whatever version you are compatible with. Paste it here, and this will make sure that this math.mx parser works in our main activity.java file, and all the calculation gets done, whether it's the basic arithmetic calculations or the scientific calculations. Now in the class main activity, we declare the text view previous calculation and the edit text display. This text view previous calculation will display the expression we are evaluating, and this edit text display will initially display the expression we want to evaluate, and later it will display the answer to the expression which we want to evaluate. Now moving on, we need to use the Oncreate method so that we can start the activity. Here in our case, the layout activity underscore main gets started. Now, as we already declared this previous calculation, it will have inside it the view, find view by ID, and we are actually connecting here the backend to our layouts we created. And this display dot set show soft input focus, having the parameter is false, helps us getting rid of the keyboard so that user doesn't input anything other than which is present on our buttons. The next thing is the update text function. Let's see what is done in this function. The first thing is we have this parameter string str to add, that is string to add. Whatever the user inputs will be passed to this parameter and then manipulated in the update text function later. The first line of code helps us to declare the old string where a text is input by the user and then converted to a string and stored in this old string. Let's say our input is this. So this is our old string. Now the second line of code is about the cursor position. So using get selection start, we can place our cursor. Let's say we place our cursor after R and before N. So this will be our cursor position, and this is of course an integer, so the type is integer. Now what this left string is, and what this left string will store is, from the old string a substring has to be extracted which has the start position as 0, and the cursor position we just determine by clicking after R and before N in our input string. So our left string will be from before N to the start, or you can say from 0th position to before N, where the cursor was previously placed. This is our left string. Similarly, our right string is again a substring extracted from the old string, and the substring starts from this cursor position and goes all the way to the last. So after N and before N, after R and before N, the cursor was previously placed. So before N is the start position, and all the way till I, the cursor, the substring is extracted and stored to the right string. So ultimately what we have from our old string is this selected portion as our left string and this selected portion as our right string. Now let's move ahead. Now display.set text and string is formatted, and what we have is what we actually doing here. What we actually are doing here is the left string, the string which is the actual input from the parameter, and the right string which we already extracted from the old string as a substring. all these three are concatenated. Let's say the string to add we have passed in the parameter as this. So this is our final string, and now the last line of the code says display.set selection cursor position plus string to add dot length. The string to add dot length is 4. The length of the string which got passed through the parameter into the string to add, the length of it is 4. The cursor position, initial cursor position was after R. Now a new string is added and the cursor position will shift by 4 places because the length of the string to add is 4. So the cursor will now come after M and before N. Now once we are done with the update text function, what we have to do is write all the functions for respective buttons. Like for 0 button push, when the 0 button is pushed, the 0 should get printed like this, and when 1 button is pushed, the one text that is 1 should get printed. Similarly for all the numbers 2, 3, 4, 5, 6, 7, 8, 9, and also for the arithmetic operators multiply, divide, subtract, and add. Now let's go ahead and see for the clear button. Now when the clear button is pushed, what happens is the whole text is set to nothing, and also for the previous calculation the whole text is set to nothing. Means the input area where the text is displayed, where the expression is displayed and the answers are displayed, both the areas become nil and empty. Now furthermore, if we have to print the parenthesis, whether open parenthesis or the closed parenthesis, we go for these functions respectively. And also if you want to have a dot or a period or a decimal, then we need to invoke this function decimal button push. Now let's go ahead and see the function backspace button push when the backspace button is pushed. So what we do here is, first of all, a cursor position is stored using the get selection start. Let's say the cursor position is after K and before Y here. And the next thing we do is store the length of the text, length of the string we have, that is Tokyo. The length of the string is 5. We store the length of the string. Now the condition here says that the cursor position should not be 0. Let's say the cursor position is 0, like before T, then obviously we won't have anything to delete, so it's invalid. The least thing is we can have is the cursor position after T, so at least T can be deleted. Now the other part of the condition is the string length should not be 0. If the string length is 0, like we have nothing inside the string, then obviously we won't have anything to delete. So this also is case of invalidity. Now furthermore, getting inside the function, if these cases are true, the length is not 0 and the cursor position is also not as 0. Now we go ahead with the spannable string builder selection and we typecast the get text to display. Spannable string builder. Now the selection dot replace, the first position we have is cursor position -1 and the second position is the cursor position itself, and that has to be replaced with nothing. For example, we had the cursor position after K and before Y. Now cursor position -1 will be before K, and the cursor position is after K. So this is our selection. Now this selection has to be replaced with nothing. So what will it become is this. Now this will become this, but the cursor position is still at this, at 0, 1, 2, 3. It's still at 3. It was before, initially it was at before Y, and after k, that is 0, 1, 2, 3. So the cursor position was at 3. It will still be at 3 after deletion. 1, 0, 1, 2, 3. So, but after deletion of the k, the cursor position should be before y, not after y. So what we do is we move the cursor a position back, so it will be cursor position minus 1, and instead of being at the position after y, it comes before y. Now let's go ahead and see the equal button push function. When the equal button is pushed, this function is supposed to be invoked, and let's see what happens. Here the user expression string is declared, and in this the input of the user is to be stored. Now this input has to be moved or shifted above in the text view. For doing that, what we do is the previous calculation.setText, the user expression that the user has input. For example, in the emulator, let's see, if you do 9 into 9, this is a particular expression. When we press equal to, this 9 into 9 expression, which is visible right here, should be shifted above and go to the text view, and instead of the expression, the value, the outcome of this expression should be placed where the 9 into 9 is placed right now. So I press equal to, and the answer 81.0 is placed in the edit text view, and in the text view the expression is shifted. Now let's go ahead. Now user expression, what we do is, in the user expression we will replace all this divide with the slash, and all this into with the asterisk, because our system is not going to understand this symbol of division and this symbol of multiplication. Rather, it will understand the symbol of division and this symbol of multiplication. Now let's go ahead, and the expression exp, what we are doing here is we're creating an object using the keyword new, expression user exp. Now what we do is, this object exp is our object, and we use dot calculate to evaluate the expression. Now this expression is a decimal or an integer value. It's a numeric value, so we have to convert it to a string before we store into our result. So string dot value of will convert this numeric term into string term and store it into the string results. The next part and the final part is we display our result. As we wrote different functions for digits and arithmetic operators and equal to, also the backspaces, similarly we are going to write functions for scientific expressions, and we actually don't have to write much of a code for each of the scientific functions. That all those things, all the calculations for the scientific functions will be handled by the parser we have imported manually previously. So what we have to do is just write the name of the function which is to be invoked, and then use the update text function which we already declared and defined, and the parameter which we have to send is just the starting part, the sign and the open parenthesis and cos open parenthesis, and similarly for other functions as well. For the pi and e, we don't need the open parenthesis, and we can just simply pass this string with pi for pi and e for e. Now we are done with our main activity.java file as well. Now let's go to the emulator and experiment a bit with our virtual device. So the back function works good. We'll restart this. Okay, now it has been restarted. Let's check. Okay, this is the portrait mode. Now let me rotate my device because I also created a landscape layout. So we have to press this one. Landscape layout activity underscore main.xml for our scientific functions. So let's clear this. Sine inverse 8. Okay, this should be between 0 and 1, I think. Yes, it works. It works again. Let's clear this. Under root 36 6. So that's pretty much it. Thank you.